Good day, everyone. Our topic for today is all about propositions. What is a proposition? A proposition is a declarative sentence that is either true or false, but not both. If a proposition is true, then its truth value is true, which is denoted by T. Otherwise, its truth value is false, which is denoted by F. We define a proposition, or sometimes called a statement or an assertion, to be a sentence that is either true or false, but not both. Propositions are usually denoted by small letters. We usually use the lowercase letters p, q, and r to represent propositions. This can be compared to using variables x, y, and z to denote real numbers. Since the truth values of p, q, and r vary, they are called propositional variables. A proposition has only two possible values. It is either true or false. We often abbreviate these values as T and F respectively. For example, the proposition P, everyone should study logic, may be read as P is the proposition everyone should study logic. In this slide, let's determine whether each of the following statements is a proposition or not. If it is a proposition, give its truth value. First is the proposition P, which is Mindanao is an island in the Philippines. This is a declarative sentence and Mindanao is an island in the Philippines. Hence, P is a proposition. Next, the proposition Q, which is find a number which divides your age. This is an imperative sentence, and so it is not a proposition. Next is the proposition R, my seatmate will get a perfect score in the logic exam. The statement is a declarative sentence, but its truth value will only be known after the logic exam. Nonetheless, it can either be true or false, but not both. Hence, R is a proposition. Next, the proposition S, welcome to the Philippines. This statement is exclamatory and hence it is not a proposition. Next is the proposition T, which is 3 plus 2 equals 5. The given equation is a mathematical sentence. Translated into English, the equation reads the sum of 3 and 2 is 5, which is a declarative sentence. It is also a true statement. Hence, proposition T is a true proposition. Next is the proposition U, which is f of x is equal to square root of x over x plus 1 is a rational function. This is a declarative statement. Since the numerator of the function is not a polynomial function, the function f is not rational, so the statement is false. It is therefore a false proposition. Then, V, what is the domain of the function? This is an interrogative sentence, hence it is not a proposition. Next is the proposition W, I am lying. Although W is a declarative sentence, it is not a proposition because it can neither be true nor false. Suppose W is true, that is, it is the case that I am lying. Since I am lying, my statement is not true, and so W must be false. The same conclusion can be drawn if W is assumed to be false. Next is the proposition P sub 1. It is not the case that square root of 2 is a rational number. While this is a declarative sentence, it can be shown that square root of 2 cannot be expressed as a quotient of two integers. Thus, P sub 1 is a false proposition. Next, the proposition P sub 2, either logic is fun and interesting or it is boring. This is a declarative sentence which is true, since students may find logic either fun or boring, hence P sub 2 is a true proposition. Next is the P sub 3. If you are a grade 11 student, then you are a Filipino. This is a declarative sentence, but it is not true. There are also grade 11 students of other nationalities. Next is P sub 4. If you are more than 60 years old, then you are entitled to a senior citizen's card. And if you are entitled to a senior citizen's card, then you are more than 60 years old. We know that it is a true proposition. This is also known as a biconditional statement since we can rewrite it as you are more than 60 years old if and only if you are entitled to a senior citizen's card. Okay, let's move on to compound proposition. A compound proposition is a proposition formed from simpler proposition using logical connectors or some combination of logical connectors. Some logical connectors involving propositions P and or Q may be expressed as follows: not P, P and Q, P or Q, or if P then Q, where stands for some proposition. A proposition is simple if it cannot be broken down any further into other component propositions. Let's have some example from above. First is the proposition P sub 1. It is not the case that square root of 2 is a rational number. P sub 2, either logic is fun and interesting or it is boring. P sub 3, if you are a grade 11 student, then you are a Filipino. P sub 4, if you are more than 60 years old, then you are entitled to a senior citizen's card. And if you are entitled to a senior citizen's card, then you are more than 60 years old. Furthermore, we can determine the simple propositions that make up the propositions P sub 1, P sub 2, P sub 3, and P sub 4. We do so in the following table. The propositions P sub 1 is using the proposition R square root of 2 is a rational number. P sub 2, F is logic is fun, I logic is interesting, B is logic is boring. Proposition P sub 3, the simple components are H, you study is hard, G, you get good grades. P sub 4, you are more than 6 years old, S, you are entitled to a senior's citizen card. The compound propositions can thus be expressed as follows. For P sub 1, not R. For P sub 2, F and I or B. P sub 3, if H then G. P sub 4, if A then S, and if S then A. So, for P sub 1, the compound propositions can be expressed as square root of 2 is not a rational number. For P sub 2, using logical connectors and or is logic is fun and interesting or boring. For propositions P sub 3, if you study hard, then you get good grades. For P sub 4, if you are more than 60 years old, then you are entitled to a senior citizen's cards. As well, if you are entitled to a senior citizen's card, then you are more than 60 years old. So that's it for today. Hope you learned about the propositions. Thank you for listening. Happy learning. Good luck.